post this for later. So when you see patterns, you can see straight lines that go up, but you'll also see straight lines that go down. And when I say going down and up, that means that we're looking from the left to the right. Every time we look at growth, we're always saying we're going from the left to right. Because some people might look at that line and say, oh, well, that's going up if I go this way. But you got to always remember, start on the left and then go right and see what the line does. Okay, and that's going to tell you whether it's going up or whether it's going down. Okay, so you have C straight line. You're also going to see lines like this. Just start off kind of slow and then go straight up like that. Okay, and then you'll see lines that come down really fast and then start to become flat. So it's not up and down. So it's still left to right. So this one, as I go to the right, it's going up, it's going up. And then here, it is going up, but it's still going right. It's just going right really slowly, okay? It's just kind of hard to see, but it is still going to the right as it goes this way. This one comes down super fast and then goes to the right. So this, when you guys see a straight line, this is called linear. And then the curve, like I told you guys, that is called exponential. They do. So when you see a curve, that means it's something that goes down really fast, but then later on it goes really slow. Or it starts off really slow and then goes off really fast. Okay? Whereas if you look at the line, the speed doesn't change. It just goes up the same speed, same rate. Okay? So these are considered growth. These ones to the right. I'm sorry, to the left. Yes. Okay, depending on what we're talking about. Okay, so this is growth. And then in exponential functions, we call this decay, which is basically just means decrease or going down. If you've heard of the word decay before, you might think of like, I don't know if you guys have ever had a pet and had to bury your pet. It decays over time, right? Or an animal's decay in the forest. Okay, so this, we can call that decay, but usually when we talk about a straight line, we just call this decrease. Okay? Now there's different kinds of equations for these increases and decreases. When it's linear, you guys know this equation, you've seen it many times. It's y equals mx plus b. The part that tells us about the growth is the m. The m will tell us the growth. It'll tell us whether it's increasing or decreasing. So in this one, our m is positive. Or we'll say m is plus. If it's decreasing, then m is negative or minus. So, and it's a little different when we start talking about the exponential functions. Okay, because when it's exponential, it's not about negatives and positives. Negatives and positives don't change whether it goes up or whether it goes down. Okay, it does change it, but not in the way that it changes this one. Okay, so now the function or the equation for exponential or curves is y equals a times b to the x. Now, if you notice, I wrote that little x really small, right? Because it's a exponent. It's an exponent. It goes on top of the number. And that's why it's called exponential. If you guys see the word exponent in that word, because the x is in the exponent. So that is the exponent. Okay. A is your start value. And then B is your growth. Now, that sounds backwards, right? Because if you guys remember, in y equals mx plus b, the b is what we call the start. So that's why sometimes people get confused when we look at this equation and then this one, because in one, the b is the start, and the other, the b is the growth. So you got to remember the difference. Okay, so the ones that you're going to see this week, anytime you see B, that just tells you how fast it's growing or how fast it's decreasing, okay? So now, and it's not about negative and positive. It's not about negative and positive. When you see something growing, the B is greater than 1. The B will be greater than 1 when something is growing. And I'm going to give you guys some examples of what that looks like. When it's decaying or decreasing, B is less than 1, but greater than 0. Just 0. Not even 0.5. It just has to be bigger than 0. Recording again. Okay, so let's say let's actually go back up here. I'm going to write a couple examples for growth when we talk about y equals mx plus b. So growth could be, and you can write this kind of anywhere on the left. Let's say 1/2 x plus 3. That's growth. Because 1/2 is positive. Because remember, it doesn't matter about whether it's less than 1 or greater than 1. If it's a straight line, this just needs to be plus. But then if it's decrease, I could take the same equation, and all I got to do is make that 1/2 negative. And now all of a sudden it's decrease. So those are a couple of examples. So all that has to change for straight lines is plus or minus. Okay, now if it's a curve, now we're using this equation. Okay, and let's say I've got, I don't know, a 2 here. And then right here, I've got 3. Okay, so I start at 2, and then the increase is what it's doing is it's multiplying by 3 every time. When we look at this one, we're adding. This one, we're multiplying the numbers, okay? So now here, another example would be, let's say I've got, the first number is 0.5. Okay, that's less than 1, all right? But here, I've got 5. So here, the A, that's just where we started. That's not the growth. So because it's 5 inside right here, that's growth. That's increase, okay? So then for decrease, let's say I take those same numbers, and now instead of 3, it's 1/3. It's 1/3. Okay, that's bigger than 0, but then it's less than 1. Okay. Now here I could put 0.5 again, but instead of 5, now I put 0.75. Remember, this number doesn't matter. It's this number. This is less than 1. So this is going to look something like this. It's going to be a decrease. Okay, so remember, the important number here, guys, is this one here. Okay, that's the one you want to pay attention to. Okay, now if it was a straight line, we would look at that number there. Okay, but right now this week we're dealing with these guys, these curved lines, exponential lines. Okay. Recording again. All right, so looking at table to function. Now remember I told you that we are multiplying. Okay, we're multiplying when we're dealing with the function. All right, so I'm actually going to write this table down in my notes. So I'm going to go to a new page here and title this Deltamath. I'll call this 7B, just so they have the same title. And then this is table, oops, my bad, spelled that wrong. Table to function, I believe, right? Yeah, table to exponential function. Okay, so we'll do a few examples from there and then we'll call it a day. All right, so remember the equation is y equals a times b to the x. A is the start. Another name, by the way, for that is principal. And not like the principal of your school. All right, principal of your school is P-A-L. This one is P-L, or sorry, P-L-E. Principal just means the start. And usually you say principal when you start talking about money. Okay, so if you start with some money, you put it in the stock market, that's your principal, okay? Or if you guys go to college and you have to take out student loans, the money that you take out, that is your principal, okay? But you usually don't have to pay just your principal. You have to pay more, and that's called interest, all right? Okay, so the B is the rate of growth. And when you see the rate of growth, it is a number that you are multiplying. Okay, that's what we want to emphasize. You're multiplying that number. Multiplying. Okay, so what we want to do is let's start with the start value. Now, I don't know if you guys remember from the y equals mx plus b equations, your start is always the number where x is 0. Wherever you see x is 0, that's your start value. Okay, so the start in this case is 5. But then the question is, what is the rate? How are we increasing? Well, what I have to do to find that, the b, is look, how is it changing from one number to the next? So if I think adding like plus 5, right, so that would be it. So if I say plus 5 though, well, plus 5 works here, but then plus 5 is not 20. So like one student here said, I have to multiply 2. Okay, so when you get a curve or that kind of growth, it's multiplying instead. So now your b is actually 2. So now the way you set this up is you go y equals, first your a, and then in parentheses, you put your growth or your rate, so the 2. And then you always just make sure you put this little x right here. Okay, that's just part of the equation. And then that's how you figure that out. Okay, so as long as you have the start value and then the rate of growth, then you can find that. There's nothing to solve. So all you're trying to figure out is what is the equation. No, equations, why we find them is to help us make predictions. Okay. So like if I want to know, and actually I'm going to show you guys something I used when it comes to football, because I've been trying to figure out if we're going to start football or not. And there's something that I had to pay attention to when it came to this function to get to that point. So you guys know I'm a math teacher, so I like numbers, all right? So what I've been looking at is, I don't know if you guys know, there's this number called the case rate per 100,000. Okay, it's this number right here. It says case rate per 100,000. What that means is how many people have COVID-19 in 100,000 people. So if I took 100,000 people, how many people would have it? Okay, so on January 19th, the government said that we had 97 people. If I took 100,000 people, that 97 people would have it. The next week, that number went down. And then it went to 67, and then to 50, and then to 35. Last week, it was 25. And actually, I want to know what it is today. So let's update our table. So I'm going to go to COVID-19, case rate of California. And then if you go to the government website right here, tracking COVID in California, you scroll down, keep going. Let's see if they updated it. Oh, maybe I went too far. Oh, they still haven't updated it. So you can see here it says February 16th. So at some point today, they have to update this. But basically, I click on our county, San Diego County down here. And it takes a second. And then you could see they give me those numbers that I had on there. Okay, so every week I've been writing those numbers down. Now, I want you to notice that as I go from, let's say, 90 to 67, that's about 30. It's going down 30. Then if I go to 67 to 50, that's a 17. Then if I go from 50 to 35, that's 15. 35 to 25, that's 10. Do you guys see how the number is getting smaller as you go from one to the next? So you can find a pattern, okay? And the rate that I found, or the growth, was 0.71. So my B for my graph is 0.71 if I was to make an equation. That way, I can guess to see what will the number be next week. Okay, so good question. So there's different things that the government measures. There's these two case rate numbers, which are kind of the same, but there's something different about them. Honestly, I don't know what it is. The yellow one is like how many people are like test positive, percent, but it's a percent. Okay, so if you take all the people that got tested, what's the percent of how many they got positive, okay? This one, honestly, I don't know what health equity, quartile, positivity, I don't know what that is. Okay, but I put it on my graph. And you guys can see, if I put a line, actually, let me take my little thing here. If I made a line on my graph, notice what shape it makes. It makes the curve, okay? So what that does is it helps me figure out, because I need to know as a football coach, and actually this is real, actually happening, I need to know when we go below 14. Because when that number is below 14, I can play games. And that's actually the truth. That is next week. I'm hoping that we're below 14 today. And I'll find out. Or if it's not today, hopefully next week. And that also affects sports, other sports that are playing. So I use that. Actually, I shared this with all the other coaches in the county so that they can kind of guess where we're at. So again, using math to help figure things out, what's going to happen in the future, okay? All right, so going back to the problem we're working on, or these problems, let me clear this out. Let me see if we can get an example. 0.05. After that, it's going to be 0.025. So, okay, let's start off like we did before. Start value, A. That's the easy one. Just look where x is 0. 0.2. The B is the one that might not be so obvious. So just like we did before, I want to figure out what is the change from this number to that number. Well, one way we can do that is by dividing. Okay, now if I'm going to do this one, what I do to find the B, so let's write that over here. To find B, divide the next number by the one before. So divide the next number by the one before. So what does that mean? So let's say I go up here and I take 40 and 20. 40 is the next number, 20 is the one before. So B should be equal to 40 divided by 20. And if you guys think about it, 40 divided by 20 is 2. The same number up here. So that should work down here as well. Okay, so when we find the B here, I'm going to take, let's say I take 0.1. I want to divide it by the number before that. Okay, I'm going to use Desmos for that. Feel free to do that. And guess what? I believe if you guys go on your Deltamath and click on the keyboard, isn't there a calculator here somewhere? Oh, it's up here to the right. So click on that calculator, and there's the Desmos calculator. So I can do 0.2, or just like it is, 0.2 divided by 0.1. And you can see right over here, oh, sorry, that was the wrong numbers. I got to go the other way. 0.1 divided by 0.2, and it's 0.5. Okay, so the answer is 0.5. That is your B value. Now, if you use that Deltamath calculator, it won't give you the fraction. But if you go to the Desmos, sorry, I meant the Desmos one. If you go to the Desmos one and do the same thing, so 0.2 divided by 0.2, it'll give you the decimal, but if I click on this, it'll also give me the fraction, which you guys can see is actually 1/2. Okay, so I can do either way. And some of you guys might already know that 0.5 equals 1/2, okay? So 2 ways to write the equation: with a decimal, first with your A, and then my B is a decimal, or, and again, these are both correct, and they'll both work in Deltamath, 0.2 with a 1/2 right here, and then X. Okay, so either of those answers would be acceptable when you are looking for the answer. Same thing when you guys take the quiz for that folder. Okay, I set it up to accept both decimal and fraction answers, okay? Okay, so again, you gotta always think though, because we're multiplying 1/2 each time, right? So I'm actually multiplying here 1/2. Now you could say that each time you're dividing 2, like you're saying, because if I divide 2, that will give me the next one, divide 2. But when we're looking for the B rate, or the B, you have to think, what do you multiply? And that's why a lot of times the number you multiply when it's going down is going to be a fraction. Okay, that's less than 1. Okay, so if you think about it, if I divide by 2, I'm multiplying 1/2. Okay, if I was to divide by 3, then what I'm doing is multiplying 1/3. So basically I just put a 1 on top. Okay. Okay, guys at home, that is it. I will see you guys on Thursday. If you have any more questions, you feel free to stick around. I'll leave this up here so you guys can take notes if you need to finish. Otherwise,